So since the beginning, I've been telling you guys that the kids that do well on this test would be the ones who understand complicated exponents. But there's more to it than just complicated exponents. Let's get to just a nice, simple, that is not a log, but you can make it into a log. Could you rewrite that as a log? That is like a super simple R2 kind of question. Can you make it a log? Well, obviously you start by just saying, well, I guess I need to write log. And then hopefully you start thinking, I guess I need a base next. And which of those seems like a base? Oh, the 10 seems like a base. In this weird instance, you wouldn't even have to write base 10, because if you have a log that doesn't have a base, you mean base 10. But I would have written it. And then you go around the horn, that's a 7, and then come back, and that's equal to x. Raise your hand if you wrote that correctly. Okay, good. That's one key skill. Here's another one. What if I give you a log? Can you rewrite it into an exponential? Give that a shot. It's the same basic idea. It's can you rewrite it? And you still use the circle of logs. I should trademark that. 3 to the 5 equals x. There you go. That's an exponential version of it. Okay. Next thing. Let's talk about those exponents for a minute. I like 9 because it has easy square root, and you can do things with it. So I'm going to say 9 to the negative 1. You should know right away what that's equal to. And if you think the answer is negative, you're doing it wrong. Then there's 9 to the 0. Then there's 9 to the 1/2. 9 to the 1 I'm skipping because it's just too easy, but we're going to go to 9 to the 2nd. And that's the kind of like the mid-level exponents. These are not the tricky ones. The tricky ones are the fraction exponents. Would you please write out those 1, 2, 3, 4 answers? Now, please share with the kid next to you what you think they are. So these were just kind of mid. They were pretty easy. 1 over 9. 9 to the 0. Anything to 0 is 1. This one's square root of 9. If you wrote that, that's fine, but you're supposed to simplify it. What is the square root of 9? 3. And 9 squared, 81. Okay, so then I said kids that were really good at exponents would be the ones who would excel on this test. So this is like you're just not, like those aren't that hard. Where they get hard is when you're in the middle of a log problem and it's like this is a 2 and this is like a 16. Oh, wait, it's a 1 over 16. And then all of a sudden, if you know how to write that as 2 to a power, this problem is easy peasy. But do you? So if I were doing this, I would write it as log base 2 of 2, and then I'd sit there and think about like what exponent do I don't, like get it to this point. So you're like, I know I need an exponent, and I got to get a 2 to be a 1/16. All right, I'm going to pause for a second while you figure out what exponent. So if I was struggling, like I can tell a lot of you are, I would be thinking through things like, well, 2 to the 1? Well, that's obviously too small. 2 to the 2nd? That's 4. It's still too small. 2 to the 3rd? That's 8. And if you stuck there because you don't like think about 4th powers all that often, you might go, well, maybe I should try 2 to the 4th, but I'm not sure what it is. Well, it was, you were at 8. You just double it one more time and you're at 16. And I must be close because 2 to the 4th is 16, but I want it to be 1/16. What's the answer? -4. Raise your hand if you had that one right. All right. A fair number of you would have got that one. All right. So I'm going to go. I have so many here. This is going to be a rapid fire, but a ton of the questions on the test are like this. So that's why I'm going to practice it. All right. So take like 15 seconds on each of these. All right. I'll start Easy. Log base 3 of 27. So right away I'd be thinking, well, I guess he wants me to write this as a 3. 3 to the first, clearly not. 3 to the second, clearly not. Oh, I guess it's 3 to the third. Raise your hand if you had it right. Cool. Now, is this the answer? No, well, the answer is 3. Because once the bases are the same, the answer's already there. All right. So you would rewrite the 27 as 3 to the third. I know a lot of you don't have that memorized. Well, you should. There's a certain number of cubes that are like really common. So let's cube a few important numbers. Like we're not going to go with 10 cubed. Well, actually we could, because that's a nice easy number. 10 to the third is 1,000. Let's go through some of the to the thirds. 4 to the third. You probably haven't got it memorized, but it might be handy to know. What's 4 to the third? Well, it's 4 times 4 and then times 4 again. So 4 times 4 is 16, and then you times 4 again. And that's where a lot of people would be stuck. It's 64. Let's do some other cubes. 5 to the third. More people know this one, I think. 125. If you haven't memorized it, you might want to know the cubes because, like I said, it's going to come down to making weird exponents like this. And if you didn't know 3 to the third is 27, you'd kind of be stuck. All right. What else? Well, 2 cubed. That's pretty easy. 1 was 2 cubed. 2 times 2 times 2. 8. Well, I've done 2. I've done 4. I've done 5. How about 3 cubed? 27. See, right up here. 2, 3, 4, 5. How about 6 to the third? Weirdly, we don't use that one that often. So we're getting to the numbers where all of a sudden we're going to jump all the way 1, 2, skip a few. 10 to the third. 1,000. Why would you ever need that? Because log that has no base really has a base of 10. And if I put like 1,000 here, you're supposed to be able to go, oh, I know that 1,000 is 10 to the third. So that first thing you do, put in the base that's not there. Second thing you do is think, I could make that into 10 to a power. And if you don't know what power, you're stuck. Just go through them. 10 to the first, no, it's too small. 10 to the second, that's 100. Definitely too small. 10 to the third, oh, it is that. Yay, so the answer is 3.
Why don't we use 3 cubed?
You want the base to be 10.
No, like we said that we don't use 6 cubed a lot. Why don't we use 6 cubed?
Because it's just gets harder and harder the bigger the numbers are. So like 7 cubed, I honestly don't even know what it is.
Okay.
Like I'd have to take a minute and actually multiply 7 times 7. I can do that. 49 times 7. I just don't know what it is. You can do them. It's just that they aren't. The bigger they get, the less likely they are to be used. Okay, so let's go back to. I said I'd do some like fairly easy ones at the beginning. Log base 7 of 49. What's that equal to? Anders, what do you think I want the base to be?
7.
Yep. So then it must be 7 to the something.
Oh, the third.
Nope, just to the second. Isn't 7 times 7 40? Please tell me it's 49. Okay, good. I'm just questioning my reality for a second there. Yes, 7 squared is 49. There we go. So the answer to this one is what? 2. Okay, good. All right, here's another one. In the midst of all these other ones, this one might seem confusing for a second, and then hopefully you're like, oh, I got that. Log base 8 of 1. Say it when you know it. 0. What? Why is it 0? Well, you won the argument. You get nothing. Or you could say this is 8 to the 0. Maybe you never understood why it was 0. It's because that. Because see, now the bases are the same, so the answer is the exponent. Oh, nah, 0. Sorry. Okay. Here's another one. Rapid fire. Log base 8 of 2. I know, it's weird. But you want that 2 to be an 8. 8 to the something. The kids that are good at the powers are going to have an easy test. It is 8 to the 1/3. Weird powers. Why? Because that's the third root. Do you get 8 to the 1/3 means the third root of 8? And what is the third root of 8? It's 2. We just talked about them in a different context. Okay, so then the answer to that one is 1/3. All right, here's some more tricky ones. Log base 8 of 1/64. How good are you with the powers? Claudia, can you tell me, not the final answer, but what are we trying to do?
We're trying to get the base the same as the exponent.
Yes, so we really want this to be an 8. And then you got to piece together, like, how could I turn that 8 into 1/64th? Obviously, 8 to a power.
You know,
Anybody know the power? Raise your hand if you feel like you got this one. Brooke, what do you say? All right, I'm gonna just start with the 2, because 8 squared is 64. I know I'm close, I'm getting a 64, you know? And then how do I get 1 over? You do a -2, you're correct. So if you're like, I couldn't have done that, well, then you're probably not gonna do real well on this test. Maybe you should practice a little bit tonight, because all it would take is to get really good at exponents, like this, and you'll be okay tomorrow. All right, here's another couple. Log base 5 of 25, that'd be too easy, because they would just be 5 squared, right? So what if I make it the third root of 25? Stretch yourself. This is the workout part. It's like where you're in the weight room, you're lifting the weights and you're starting to feel a little heavy. If you quit and just put the weight down, you won't get any stronger. I know if you just sit there and stare at it, it's not a great strategy. I would start by writing log base 5 of 5, and then I'd try to figure out pieces of it. Like, well, I know it's got to have a 2 in it. 5 squared is 25. Then that's part of the answer. And then you just got to go, what would make it have a third root? Oh, the roots are on the bottom, just like in plants. The answer's 2/3. Who had 2/3 on that one? Oh, a lot of you. Good. Okay, here's another tricky one. Just log, no base, 100. If you're good at exponents, these are like, bam. I have a feeling I'm going to hand this test out and some kids are going to be done with it in 10 minutes. Seriously. So you should know the base is 10, right? And then this must be 10. 10 to the what? 10 to the first? No. 10 to the second? Yes, 10 to the second. There we go. The answer's 2. That's all there was to it. All right, they can get harder. Log base, well, nothing, no base. 1/1000. This is right in the wheelhouse of the ACT. They do this kind of stuff because it seems so simple. Now, the reason that they might not do this exactly on the ACT is because they don't want to give an advantage to people who have a calculator. And it would be an advantage. If you had a calculator here, you'd literally just type in log parentheses 1 divided by 1,000 parentheses. Like, you could just type it in. Okay, so this exact question wouldn't be on the ACT. They'd throw a variable into it so that you couldn't just type it in. But we'll talk about that later. For right now, you should just know this is base 10, and then you know this must be 10 to a power, and then that's what I would start with. And then I'd start piecing together. 10 to the first? No. 10 to the second? It's 100. No, I'm getting closer. 10 to the third? That's 1,000. And then I got to make it 1 over, so it's -3rd. Raise your hand if you had that one right. Okay, good. You're becoming stronger. Are you this strong, though? ln e squared. Jack, do you remember my sage words of advice? Whenever you saw ln, you should what?
Rewrite it as log base.
He remembers. Log base E. And if you did that, that was the first step. And then you go, huh, base is already the same. The answer's 2. Done. So I do recommend anytime you see ln, you rewrite it as log base E, and it'll become more obvious what you're supposed to do. All right, they definitely can get harder though. How about ln of 1 over E, and it's a square root of that? When it's difficult, do one thing, and then it'll be a little better, and then do another thing, and it'll get a little closer. Yes?
These type of questions like R2s or R3s.
These can be it's a fine line. The really tricky ones are R3s, the less tricky ones are R2s. So I have done problems today that have been R3s, not the exact questions from the test, but just like things you're expected on R3s, and I've already done questions that are R2s. Just the harder ones are R3s, easier ones are R2s. This one, it's definitely up there in the tricky category, so I'd say this is an R3. I wouldn't say it's a hard R3, I think it's kind of an easier R3. Because if you know that ln means log base E, it becomes more obvious that that just needs to be e to a power. And e to the first would definitely not be enough, but I got to get this 1 over in there, and that's a negative power. And I got to get the square root in there. I didn't put the 2 because it's the common root, and you can assume it's a 2. So then this is 1/2. That was one of the tougher ones we did. I shouldn't have said that it was an easy R2. That was a tough R3. How many of you would have pulled it off? All right. This is called scaffolding. We started off with fairly easy ones, and I've been building you up. Now it's pretty tough. They can get worse. All right. Log base 8 of the 3rd root of 64. 1 over all that. What? You can do it. Now that would be like the big kahuna. So remember what I said about take one step. Riker, don't tell me the answer, but tell me one thing we could do to make it more clear what we're doing here.
Change the 64 into 8 squared.
Ooh, interesting. Okay. I wasn't thinking you were going to say that, but that would work. 64 is 8 squared. That's true. Okay. What I was thinking you were going to say is make it log base 8 of 8 to a power, because that's fundamentally what we're trying to do is just figure out that question mark. All right? And then I would start piecing through in that little question mark, 8 to the what? Well, 8 to the first obviously isn't even close. 8 to the second involved? Yeah. So then this must be an 8 to the second, but it's obviously not just that. So that's how I'd kind of piece through it. Raise your hand if you think you got this one. It's the hardest one I've put up. That's a lot of people. Alex, give me your best shot.
You can't leave a 3 and then you have the over 1, so you move the 3 to the bottom of the 2. Well, like you already canceled out the
You are correct. There's a 3 down there. Yes.
and so you have it over 1, which would be 1 over 2/3.
So close. That 1 over tells you a negative. Tells you a negative. Boom. Negative 2/3. Raise your hand if you had that one right. And that's a lot of you. Sweet. I feel good now about this test tomorrow. All that's left is can you do the graphs? So these were hard yesterday, I think. It's harder than I thought it was going to be for you. If I gave you this, you're supposed to be able to know where the asymptote is. Hint, it has to do with the argument. And you're supposed to be able to make me a list of 3 points and the asymptote and then be able to graph it. I'm going to pause for a second while you give that a shot. If if you put in -3 for the x, you'll get the asymptote because it makes the argument part 0. You are correct. So we write -3 ASYM. If you didn't know that, you need to know that. It's whatever makes the argument part be 0. Yes?
No one used subtract 2 from it? Or
Nope. Nope, because that's not in the parentheses. Just what makes the argument part. Just the parenthesis part. 0. Okay, so a way to like think that through, Garrett, is like, if I just asked you, which way did this thing move? Isn't the 3 the thing that moved it to the left?
Yeah.
And that's why the asymptote is moved left 3 like that. And so that 2 didn't move it
Yeah.
left or right. So then it doesn't affect the asymptote.
That makes sense.
All right. So, Garrett, do you have another point that you think is on this thing? How about this? Pick a number for x, and I'll put it in, but try to pick, like, just not a random number. Try to strategically pick an x number. I can tell I've caught you off guard. I didn't mean to. I will come back to you on a different one. Somebody, give me an offer of an x. Tell me an x.
Wouldn't that
Oh.
-4 work?
Oh, I never heard you. If that's what you, if you said -4, I apologize.
-4, 'cause then
Okay, hold on. So then that makes the argument part -1. Can't have an argument that's negative. So nope.
To -1.
-1. You want me to put in -1? That will do something, because at least this is a positive number, but it's log base 4 of 2.
you put 1 in. 'Cause then it's log base 4.
Okay, wait, just one thing at a time. She suggested -1, and I'm just trying to show her that that would mean that I was doing log base 4 of 2. And log base 4 of 2 doesn't work so well. So, I mean, it's not actually impossible, but it was really tricky. So can you give me a nicer x to put in? Garrett, you got a nicer x?
1.
1. I agree. That'll give us a nice point. Because this part is 4 now, and log base 4 of 4, we all know that's an easy answer. It's 1. And then you take the -2, and you got 1 minus 2, which is -1. That's 1 point. You got to find 3 points. Find me 2 more points like that. I'll pause for a second. Let me give this a shot. This is the part where you're lifting the weights. A little mentally fatiguing. Mason, can you give me a number that you think worked nice? It's okay. 5. 5 plus 3 makes 8. And I had that same exact suggestion from another kid, but let me show you what happens. Log base 4 of 5 plus 3 is 8. And then I have a -2 over here. So then this part right here, it tempting because it seems like that 8 is like 4 to a power, but it's not. It's 4 times 2. It's not 4 to a power. So 5 does not work as well as you would think it would. Who's got a suggestion? Yes.
You do 13.
13. Have you lost your mind? No. That's going to work perfect. You know why? Because we have log base 4 of 16, which is just 4 squared. So then that whole boxed part is just 2, and then 2 minus 2 is 0. So 13 comma 0. Question? Is that, yes, or comment or
What -2 were?
-2. I'll check for you. If I put a -2 right here, and I put it in here, now this part will be 1. Oh, you won the argument. Nice. So what's that part equal to? You won in the argument, you get what? 0. And then you subtract 2. Final answer? -2. -2, -2. All right. So, when I was sketching in my graph, I didn't know where those points are. Now I have 3 points. Yay. 1, -1 is down here. 13, 0 is like way over here. And -2 is like down there. Do those look like they're kind of curving towards where they're supposed to be? I feel like they're good. It's going off that direction. Starting to go down, starting to get closer to the asymptote. There we go. Those are my 3 points. I've got the asymptote in. I'm good. Now, noticeably harder for you guys than I still kind of baffles my mind that these are that hard for you. But we're just going to do one more like that because you definitely have to graph. There's easy graphs and there's hard graphs. I think you'd all be able to handle the easy graph, but I thought that last one didn't be that hard too. So let's do log base 3 of x. Let's just start with an easy one. Let's make sure everybody builds up some confidence here. Nice easy graph. Find me the asymptote and 3 points. One more hard one, and then that's it. And you'll have a practice test you can use tonight to study for this thing. Boy, you will thank yourself later if you spend an extra 15 minutes more than you had to, so you can just get an A tomorrow. Because if you get the C tomorrow, you know you're going to want to retake it, because it'll have knocked your grade down right before the semester ends. Spend an extra 15 minutes. Avoid the retake. And I don't mean just total of 15 minutes. I mean 15 minutes more than just barely doing the minimum. You know, add an extra 15 minutes more. Iris, can you tell me something we can put in for x? 0. If you have a 0, you're going to find the what? Yes. If I was graphing it, the asymptote is at x is 0. And then, give me another point. Somebody offer. George.
1.
You won the argument. So, what do you get?
0.
0. 1 comma 0. Over 1, up 0. It's a dot right there. Jack Sexton.
3.
3. You skipped over 2 because log base 3 of 2 is not nice. But log base 3 of 3 is 1. 3 comma 1. Over 3 up 1. I got 2 points. Is that enough? Nope. 9 does work, and it's probably graphable. Like, it's not so big that it's off the graph. So then log base 3 of 9 is really 3 squared, and so the answer is 2. So I put in a 9, I get a 2. And now I got 3 points in the asymptote. I can just start drawing a line. There we go. Graph the log. Now that was the easiest kind. It didn't have any stretches or shifts in there or whatever. So that's like an R2 level. Let's do one last R3 level log. For log base 2 of x minus 3. Find the asymptote and 3 points. And this time, just to save time, don't even graph it. Just find me an asymptote, 3 points. Sophia, can you start us off with the asymptote? It is 3, because it makes that argument part 0. I want to give enough time so you can finish this, so I'm going to pause for a sec. All right. I would submit that the numbers you probably used were 4 and 5 and 7. If you didn't try those and see why they work nice. The asymptote's 3. If I put in a 4, I have 4 minus 3 is 1. I won the argument. I get 0, and even 4 times 0 is still 0. Then I put in a 5, and now I have a 5 minus 3 is a 2. Log base 2 of 2 works nice. Log base 2 of 2 is 1. 1 times 4 is 4. And last but not least is the 7. I put in a 7. 7 minus 3 is 4. 2 and a 4 here. I'm going to rewrite this thing. 4 log base 2 of 4. Oh yeah, that's like the kind we practiced earlier. That's 2 squared, so the answer is 2, and then times that by 4 makes 8. So I go over 7 and up 8. I go over 5 and up 4. Over 4 and up 0. I got 3 dots, and I've got the asymptote. And there we go. Feel like you can do that? All right, test is tomorrow. There's a practice test, and it does count as homework. Every homework assignment you blow off is like taking your grade in here and subtracting off, at this time of the year, about 0.3%, which may not seem like that much. But when you blow off 3 homework assignments, all of a sudden it's down 1%. Don't do that to yourself. Besides, it's really good practice for the test. Get it done. Answer key, check it. That's all I got for you for today. Oh, wait, stop. There's one thing I forgot. This is one of those little dumb patterns that you probably know, but if you don't, you're toast. What's that answer? It's 10. Do you remember this one? Bases are the same. This is a base in its own way. This is clearly the base of the log. The bases are the same. The answer's already there. The answer to that is just 10. That can look weirder. 10 log 3. And you're like, I don't see the bases are the same. It's because I didn't write in the base. But the base is 10, so then the bases are the same, so the answer's already there. And what's the answer? 3. If you want to know exactly why that is, I explained it on the first day I showed you, but I will just do this. If you want to know how to do that, I'll show you up at my desk. The lessons run long enough. That's all I got for you for today.